I'm Dr. Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. Today we are discussing working memory.
Working memory is a specific type of memory that allows us to hold small amounts of information in our minds for a short period of time. It is closely linked to attention, which means that developing better focus and attention can be greatly aided by improving your working memory. Therefore, if you're interested in enhancing your ability to concentrate and focus, understanding what working memory is and learning some techniques to boost it can prove to be very helpful.
To you. In addition, I will talk about tools to improve working memory, and I'll also compare working memory to other forms of memory like long-term memory and short-term memory. And through that understanding, I'm confident that you'll be able to develop better focus as well as be able to commit certain forms of information to your short and long-term memory stores.
Dr. Huberman says, when we talk about memory, most people think of the ability to remember things for a long time, like the names of states and countries, directions, and even our own name. There are two types of long-term memory. The first type is declarative long-term memories, which are things we can declare like facts about ourselves, the world, or others. Comparing working memory to other types of memory can help us understand it better. When we say working memory, we mean the memory we use to hold information in our minds while we're working on something. To make it easier, we can think of it like the memory we use when we're doing mental math or solving puzzles. Dr. Huberman states elsewhere, it's important to remember that different people have different needs when it comes to understanding information. Using everyday language, keeping sentences short, and being direct can help make it easier for everyone to understand. Procedural long-term memories are memories that help us perform certain procedures, like riding a bike or driving a car. These memories can become reflexive and stored in our long-term memory, even if we are not consciously aware of doing them. Long-term memory is not the focus of the discussion, but the speaker mentions a key structure in the brain called the hippocampus, which is essential for the formation and storage of long-term memories. The hippocampus is part of a larger neural network that includes other structures and is named after the seahorse. The brain has two small structures called hippocampi that look like seahorses. They help us form and access long-term memories. If the hippocampus is damaged, it can cause problems with memory. This means people may experience difficulty remembering things they have learned. There is much more to know about long-term memory, but this is what we know so far.
Memory. And short-term memories are the sorts of memories that we maintain for somewhere between a few minutes and potentially a few hours, maybe a little bit longer. But only a certain percentage of that is passed into our long-term memory. So for instance, if you listen to this podcast or you go to a course lecture, whether or not that lecture is about cognitive material or whether or not it's about learning a new physical skill, regardless of what you learn, you're only going to learn a certain amount of that information.
Short-term memory is a cognitive function that enables humans to hold information for a brief period, typically ranging from a few minutes to a few hours. Short-term memory serves as a temporary storage bank for information that may or may not be transferred to long-term memory. It is a crucial aspect of learning and retaining new information. However, only a certain percentage of the information held in short-term memory is ultimately passed into long-term memory. Whether an individual is learning a new language, acquiring a new skill, or listening to a lecture, they will only retain a certain amount of information. Research suggests that individuals tend to remember more information in their short-term memory stores immediately after being exposed to new information than they do later. In other words, our short-term memory stores only retain a small percentage of the information that we perceive. The neural circuits for short-term memory and the passage of short-term memories into long-term memory involve various brain structures. The hippocampus plays a crucial role in the transfer of information from short-term memory to long-term memory. The actual passage of short-term memories into long-term memories occurs in part within the hippocampus.
And a lot of people don't know this. Some of the memories that we think of as long-term memories are actually distributed into the neocortex, which is the outer portion of the brain. Now, the point here is less to fill your mind with different names of things and nomenclature, but rather to get you thinking about what's involved in creating short and long-term memories. And equally important, that even though the hippocampus is critically involved in the formation of short and long-term memories, that The formation of short and long-term memories is really a network phenomenon. In fact, among the more important themes that comes up again and again on this podcast, anytime that we're talking about neuroscience, or actually biology in any case, is that rarely, if ever, is there one location in the brain where something happens. Typically, it's a network phenomenon, meaning it's the collaboration of a bunch of different brain areas passing information from one location to the next and storing it in a kind of distributed way. Now, another key thing to understand about working memory and how it is different from short and long-term memory is that the formation of short and long-term memories almost always involves neuroplasticity. Neuroplasticity is the nervous system's ability to change in response to experience. Now, there are different types of neuroplasticity. So often when we hear about neuroplasticity in the popular sphere, people don't emphasize that there are different types of neuroplasticity, and it's worth paying a little bit of attention to what those different types are.
Yes, like you, I am hearing these words for the first time, or I have heard them before, but I don't know what they mean. So I will try to explain the words and definitions that the doctor has mentioned in this video in simple and common language. Neuroplasticity is a term used to describe the brain's ability to change and adapt over time. One example of this is a process called long-term potentiation, or LTP. When neurons fire closely together in time, their connections are strengthened through LTP. This concept is often referred to as fired together, wired together. Although sometimes mistakenly attributed to Donald Hebb, who did discuss neuroplasticity, there is still much to understand about LTP. Nevertheless, this is a basic overview of the concept. Let's simplify it with a straightforward example. Imagine your brain is like a garden, and thoughts are like pathways in the soil. Neuroplasticity is like the garden's ability to change and adapt. Now let's talk about long-term potentiation, or LTP. It's like making a path in the garden by walking on it frequently. The more you walk on a specific route, the clearer and more defined the path becomes. So, when neurons, tiny messengers in your brain, fire together, meaning they send signals at the same time often, it's like taking a walk together on the same path. The more they walk together, the stronger their connection becomes, just like the path getting clearer and more defined in the garden. This idea is summed up as fire together, wire together. It's like saying, the more often you and your friends walk the same path in the garden, the stronger your bond becomes. Even though we might not completely understand all the details, think of it like not knowing every plant in the garden. This is a basic way to look at how our brains adapt and learn through experiences.
So for now, think of LTP as any time that some small group of neurons, could be 2 neurons, could be 2,000 neurons, are very active closely together in time, and they have access to one another physically. And the consequence is often, not always, but is often LTP. That is the strengthening of those connections such that after that barrage of activity subsides, those neurons can speak to each other. They can communicate through electrical activity and chemical activity much more easily. Their communication is more robust. It's like removing a wall between a conversation such that the conversation can take place more fluidly. Now, there are other forms of neuroplasticity, including LTD, long-term depression, which unfortunately, the name often calls to mind ideas about depression as a psychiatric or a psychological symptom, but it has nothing to do with that.
Long-term depression, LTD, is the weakening or removal of connections between neurons called synapses. It is the opposite of long-term potentiation, LTP, and both are important for learning and forming memories. When we forget things, it's because some memories have been removed. Some information is never forgotten, while other things are almost always forgotten. Neurogenesis is the formation of new neurons, and it's the third type of neuroplasticity. In animals and humans, neurogenesis is robust during development. There are many other forms of neuroplasticity like spike timing dependent plasticity and paired pulse facilitation. Neurogenesis is the process of forming new neurons in the nervous system. It occurs extensively while we are growing up. People often talk about neurogenesis in the context of adults because it is fascinating to think that we can add new brain cells later in life. It is important to know that the amount of neurogenesis that occurs in the adult human brain is tiny when compared to other mechanisms for forming and retaining memories. These mechanisms include long-term potentiation and long-term depression. Although new neurons can be added to the adult brain, including in the adult human brain, they are not added in great numbers. Some new neurons may be added to the dentata gyrus of the hippocampus. While neurogenesis is interesting and important, it should not take away from the more common mechanisms of neuroplasticity. Neurogenesis is not the primary mechanism for the formation of memories. When you learn something new, your brain stores it in short-term memory, then passes it to long-term memory for recall later.
Neuroplasticity. Okay, so I don't want you to get the impression that there's something wrong with my memory and that I forgot that this episode is not about short or long-term memory, but it's about working memory. And indeed, I have not forgotten. So now is where I tell you why I've been talking about short and long-term memory and the mechanisms of those. Because I want them to provide a stark contrast for what we call working memory. Working memory, as far as we know, does not involve neuroplasticity, or at least if it does, it's not a particularly robust aspect of working memory. Rather, working memory is the reflection of a particular neural circuit running an algorithm over and over and over for different types of information, but the information isn't stored, it is actually intentionally discarded. Now, what sorts of daily activities and life activities would require working memory? The answer to that is basically everything that you need to do, but that you don't want to remember. Now, what types of things would those be? Well, let's think about it.
Most of us learn to tie our own shoes at some point in our lives. If you know how to tie your own shoes, you do it without thinking about it too much. However, when you wake up in the morning, you might need to remember to go for a jog, make a cup of coffee, find your shoes, and tie them while doing other things like making a phone call or having a conversation. It can be a lot to remember and handle at the same time. 1721. Working memory is the process of taking in critical information for a short period of time, which is necessary for sequencing your actions. The sequence is then forgotten, as in, for example, putting on your shoes before going for a run. It's a given. If you enjoy a cup of coffee or tea before your morning run, for instance, you need to follow a series of actions such as hydrating, making your drink, drinking it, putting on your shoes, and heading out the door. Proper sequencing of these actions is essential, but you don't want to commit them to your short-term or long-term memory. Working memory is important for remembering and forgetting information quickly. It's involved in everything you do, from morning to night. Some people lack or have reduced working memory, making sequencing activities challenging and requiring assistance from others. This highlights the importance of working memory. Challenges with attention, focus, and working memory can make life difficult. Today we'll
Dear friends of Charismatic Mind, I hope you have enjoyed watching and listening to this video so far. Dr. Huberman's valuable research has resulted in the creation of this video, and we aim to provide simple explanations for difficult words and terms discussed in it. We hope that you have learned valuable information from Dr. Huberman's presentation. In upcoming videos, we will delve into techniques to improve our short-term and long-term memory, as well as exercises to expand our mental capacity. Part 2 of Dr. Huberman's video series will feature a test that we can take together to measure the strength of our mind and discover ways to strengthen it further. If you'd like to join us on this informative journey and learn valuable techniques and exercises, please hit the subscribe button to stay notified of our upcoming videos.